Well, hello everybody. Welcome to November 4th, 21 distribution demo. This time I'm actually not going to be demoing anything in particular. I'm going to be walking you through some of the fun reasons why our cloud native images are actually as big as they are. Some of them are, some of them aren't. Some of them that are actually decent, some of them that are like, wait, what happened here? Okay. There. The problem is we have CNG and some of the images are ridiculously large due to technical debt. Some of that is organic growth and some of that is, oops, we actually need to fix this pattern. So I'm going to just start right with the first impacts here. If you have a container and it's 1 gig, right? That's 1 gig in size. Its contents are 1 gigabyte. Okay. Compressed, when you send it off to the registry, it's smaller than that because it's compressed. But on disk somewhere, whether it's in your Kubernetes cluster, on your Docker instance, whatever, it has to be decompressed and run from there. You're taking a gig's worth of space. Okay. Now, take that, do the compression, you get, let's call it 50% compression, right? The compressed image is now 500 megs, right? Now let's take that and let's ship that over the wire. How much did it cost us to send from the runner to the registry? 500 megs. Probably not a lot, unless you know that we're doing this a couple of 100 times a day. Starts to add up. Okay, so now let's look at what does it actually cost us to host that 500 megs in object storage for who knows how long, right? Again, not a big deal till that's a couple of 100 times a day, because remember, how many images do we have and how many are getting built daily, not just by our team, but by our team in the review process as a part of the upstream Rails, right? Because they use us and they use a mirror and they build all the images from their code base too, right? Now, when a customer pulls, we're paying egress cost, right? Every time, no matter what we can do. So if our Gitlab container is 1.5 gigs, as an example, we're at best compressing that to roughly 700 megs. So every single time somebody tries to start Gitlab and it's not on the node where they have it set to pull policy always, they're pulling 700 megs from us. Now, how many people do this daily? I can tell you that our team does it at least a dozen times a day, just in our environments, right? So that doesn't seem like much, again, until you start adding that up repetitively. And remember, we test in GKE and AK or EKS, and we're considering any other places we can manage to do this. So how many times do we do that for every single run of the pipeline? Just our team, not including customers, not including other teams in GitLab. That's a lot, right? Now, the second thing is, if I have to download 1.5 gigs, I have to download 1.5 gigs and then I have to extract it, right? So 700 megs over the wire, and then I have to have it land on disk, and then I have to extract it, and then I can actually start the pod. Does a GitLab container take a minute to start because it took a minute to start the program? Or does it take a minute to start because I have to download, uncompress, and then start the program that starts in about 5 seconds? If we can decrease the container size, we're not paying as much for storage, and neither is the customer. We're not paying as much to transfer it. We're not paying as much to store it. And everything actually starts faster on fresh installs or upgrades. Okay, this is a real problem when you look at it at the scale that we're talking about. The next thing is contributor time. Okay. Let's face it, the CNG, who's stuck their nose in there and tried to change something, anything, add a component, figure out which version goes where and how the image even comes together. The documentation is lagging. That's not helping anyone get on boarded with how the CNG works when it comes to the images. But then it's also their money because they've got to pull and they've got to store it and they've got to rebuild it, right? So if they have a fork of ours and they're running their pipelines on their runner and it's a part of their 10 gig limit, oh boy, don't run more than 3 pipelines, because that's 10 gigs of storage. Bit much, folks? Yes, I believe it is. So if they're trying to work on something for us and they're doing it in a fork and they're not doing it locally to try and build these things, that rebuild cost of transferring storage and transferring storage and transferring storage, right? If they're pushing to our registry from wherever their runner is, that's an ingress cost. And it's our storage bill, but it falls back to them because it'll hit their storage limit eventually. Ruh-roh, right? So now that we've got an understanding of why these images being big is a problem, okay, between customers, contributors, and our own OpEx, it's a problem. There's a couple of related epics that we already have, and some of them have been open for a while that we've been slowly refining over time. The big one I want to show first. This is nothing confidential, I believe, so I'll hit share screen. Zoom bar, get out of my way. Thank you. The sheer thing is that the pipelines and the artifacts, the whole setup right now is just not that efficient. We have issues. A lot of things can be streamlined. A lot of it comes down to process, right? We've got to get things taken care of in how we're doing the container definitions, the methodologies that we're using inside of those. We've got to make sure that the CI is optimized. We need to make sure that we're cleaning up stuff that doesn't need to be there anymore. How many MRs have we had that built containers that tagged on their version, and then when was the last time we cleaned up the registry? Like consciously cleaned up the registry.
We clean up the registry?
Yeah. Mitch, I think you and I sat there for like an entire day just hitting delete and waiting and waiting and waiting for all of these tags. And that was a massive amount of cleanup, right? Beyond just that, the contributor experience has to get better. That's on us. One, because we need to clearly define our processes. We have to clearly define the behavior patterns that we expect, but we also need to make sure our documentation stays up to date. Okay. Beyond that, we still have other things that people are asking for. And Stephen, you saw the other day that I brought up. Someone's like, "Hey, I can't install the operator on a T4 instance in AWS." Those are Graviton, by the way, folks. Because we only build for x86 64, there are no CNG images for ARM64. So even if the operator could do that, it wouldn't be able to actually deploy GitLab because we don't have the images for it, right? So it's a distinctive retro kind of problem. We have customers that actually ask for this. We have a certain number of customers who deal with ARM hardware or make ARM hardware or ARM related things that want to be able to run GitLab on their stuff, but they can't, which is kind of mildly embarrassing. This is a future item, but before we can really do that work, we have to make the rest of the work better, right? The next one is really the important one, which is 6691, which is actually working through all of these problematic things. Some of these are, we should actually use shelljack. We should consider like actually having a visible method of seeing what the old version is versus what this version is, or at least at the end of the job, say this thing is 1.5 gigs, and we can go back and look at it and be like, oh, you changed the Gitlab image and it's 1.5 gigs. The version on master is 700 megs. What happened here, right? But one of the largest things we have is just the junk in the images. and this is where I say some of it comes from organic, some of it comes from, wait, what happened in this process? If I look specifically at the replacing the base images, we did a breakdown of which applications actually need Ruby versus which ones actually have Ruby container-wise. And the big ones that come out of it are Workhorse, Shell, and Pages. These are Go programs that, as far as we know, don't actually need Ruby to be there. Now, to begin this work, we had to do a bunch of things. We had to figure out how to take Ruby out because we were using it for ERB. So you'd have all of Ruby for the sake of ERB. We have now implemented Gauntlet, which gives us a small Go-based runtime that we can stick in all the containers and it just works. We've implemented changes to their charts for these 3 containers so that their configuration is rendered via Gauntlet instead of through ERB. But now we go back and go, hey, can we take Ruby out? Can we actually take Ruby out and not have these be based on Ruby? Well, for Workhorse, we need to just make sure the thing actually needs Ruby. Does it? Maybe there's something it calls out to. We need to be sure. For Shell, we know there's no need for Ruby at all anymore. They specifically pulled out all that requirement. However, I tried in the past and I ran into the same issue that I then turned around and ran into when I tried to do it with Pages. All of our entry point behaviors that do set config and exec env and everything else are in GitLab Ruby. So those images have to be based on GitLab Ruby or they don't know how to configure themselves. Oops. And that's a matter of technical debt because we intentionally used GitLab Ruby because we knew we had Ruby, therefore we hit ERB, and everybody in the team and company were familiar enough with ERB that they could all help us get it going. It was an accelerant to the project, no argument. But now, how much are we adding to the image just because we're based on that, right? There's a simple question. If we can put Gauntlet in the image and it's like 4 megs, or we can put all of Ruby as a base runtime, which is like 300 megs. A little bit of a tip of a scale there, right? Well, before we can actually remove Ruby from these images, we actually need now to make a base image that actually has, this is Debian with curl and CA certs and the bare minimums, plus our init patterns. That's it. That's all it needs to have, right? Everything else can then be based directly on that and then include the things that they need. Much simpler, much more straightforward, but now we get a consistent base that we come from. So when we're doing apt-get update, we're not doing it in every single container because then you don't have consistency and you don't have a shared base image that everything builds off of. Which tab was I on? So here's some big things. And what I'm going to do here is I actually don't have the Gitlab issue in here. I should, but it's not in here. So let's go back for a second. We'll talk just about Gitlab, and I'll come back up to the next points in a minute. Gitlab in the Debian image versus the UBI image is wildly different. Like, how is the Gitlab image under a gig in UBI and almost 3 in Debian? The what now? That's a problem. Okay. So if we go look at Gitlab and how it's built and what's going on, Gitlab and anything that it needs should effectively be artifacts that we stick into the image, right? Because we don't need their sources unless it's Ruby. We don't need anything that it puts in between. You need the output binaries and you need them to be able to operate with anything that they call upon. That's all you need. And then we go look at how the images are actually built. And if I look at the Gitlab image in the Debian form, so straight Docker file, right? We have from logger and from image, which is git base, and then from the tag. And if I scroll down, there's no additional froms, which means all of Gitlab is actually operating effectively from git base. Okay. Now that's a plus and a minus, but let me come back to this because I want to show that we're taking a very large image and then adding all this stuff to it. And somehow, in particular, this chunk right here, this download and compile Gitlab, results in a 1.8 gigabyte layer just for that. For whatever
Jason,
reason, yep.
I was just going to say, could you do your anti-flicker trick when you have a second?
There you go. Thank you.
Thank you.
Sometimes it's there, sometimes it's not. It depends on the particular graphics update I did. So I'm going to run dive here and just let this pull up. And we're going to look into this one. I do have, here we are. I have this set up here to try and figure out what's going on. And this here, this 1.8 gigs is a significant portion of whatever just happened, right? And I did trace it down. You can see that's the from. So there's git base. There's actually, that's Debian way below here. When we get down in here, where does 1.8 gigs come from? When I trace this down, it actually comes from specifically this stage, right? Now, if I look at this, okay, I'm going to go and dive, go to the other window, and then I'm going to take out anything that we removed or did not modify. Okay, let me just collapse bundle. So this is there's 18 megs of Gitlab, 900 megs of GoMod. Ouch. Okay. So there's a big chunk right there because we're not taking only the export artifacts. It's a massive chunk of that. All right. So here's all of the Ruby, which to some degree, good chunk of this probably needs to be around. All right. So just collapse a little bit. Right. Okay. So now we're into what we're adding in terms of user bin, right? And what we basically have is, I'm going to control B and take out any attribute. Nope, I want to see those. Okay. Anything that's in orange is something that has been modified. Anything that's in green is something that was actually added. So we've added these contents when it comes to the user bins. And these are the executables that we have actually stuck out there. Here we have all of the extensions that we rendered as a part of Ruby. This is not unexpected because those are the things that we're adding when we do the linguist installs, protobuf rebuilds, all these things. To some degree, a lot of this should actually be there, right? Let me see if I can just collapse a bit of this. Compressed, thank you. All right, so there we are, going through that. There's action pack, action view, active support. I'll admit, I'm a little surprised to see this much of action, but maybe that's a question of where's it coming from. just going to collapse all of the gems. The Ruby gems is 578 megs. Right. Just in, I can't tell you exactly how much we added versus how much that is just modified or updated. But I'm going to bet most of it was added. Now, from that, of course, we have specifications. Do we actually need that? Maybe we're forgetting to do our cleanup on our gems. And then we have the user local bit, which is yet again another item in our path. And this has all the Gitlab bits, right? So the things that we really care about are the binaries and the Ruby requirements to operate, right? So if I collapse all of the extensions here, we added a significant chunk in our Ruby gems. We added a relatively large number of things in Gitlab throughout the binaries, which I want to point out, 47, 37, 29, 26. This is one of those instances where a Go multi-entrant would probably be super efficient in comparison to having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 25 to 47 megabyte binaries.
Gotcha. And that's just for all the command line duplicate to handle command line stuff for any.
Right, there's the actual
binary.
executables. So like the Gitlab server itself, the prefix server itself, Gitlab's SSH command handler, right? These in particular, this batch, we can ask, hey, Gitlab, can you improve this? Your outputs are this big. Is there anything we can do to make them smaller? But our issue within this container is, why do we have 900 megs of Go compilation content? That's 50% of the difference between Debian and UBI, just because that junk is sitting around. Right, like that's a legit oops. Now, if I do the same command, but I do it for the UBI image, as an example, look at the fact that this has a Docker file build and a Docker file UBI, right? $438 megs. That's us actually doing the add for the Gitlab content.
It kind of is like a multi-stage Docker file, right? Because we're building the components outside of the Docker file and copying them in.
Effectively, yeah. So
there's
UBI,
no
for the most part, effectively enforces multi-stage patterns and ensuring that we're only installing the artifacts into the running container or the runtime container. Yeah. This is just a perfect example of, we did it right in one place. Now we need to do it right in the other place too. Okay, so that being said, I'm going to go ahead and, where are you? Here, minimize. Oh, there it is. Add existing issue, paste, and make sure that gets added in. That's just the massive case in point that I want to give as an example. Who's anybody, for anybody that's interested in this? Okay, so I'm at 56 past, scheduled for about a half an hour. What I want to point out here quickly before I let other people to actually have some input is, because we only need the runtime capabilities in these images, streamlining them for that appropriately will significantly impact the size of these images. And Gitlab is a great example, and that's why I chose it. There's absolutely no reason it needs to have all of the Go content. Doesn't need to have a Go compiler, doesn't need to have anything else. It needs, this is my runtime, execute. We can reduce the contents which happens to also reduce the attack surface for those things that don't need Ruby, don't expose Ruby, right? Size reductions alone. Pages saves 180. Shell saves 900. Yeah. We've seen GitLab can easily save between 900 and 2 gigs. Okay. Wow. Workhorse, we're not sure yet, but it's probably going to save us at least 180. It should save us at least as much as Pages, assuming we know all of its actual requirements.
Yeah, that's the trick, right? Is you have to know the requirements. I think that's maybe why some of these things build up over time, right? Is, you know, finding cycles to prune all that. I think is something that folks will have to plan for, not just our team, but in general, right?
Yeah.
I think
Just the one thing I want to show as a quick counterpoint is the Workhorse Debian image, only 630 megs. Who wants to take a guess at how big the UBI image is? What? It's almost 3 times larger in UBI because of something. But what? Yeah. I think maybe it's time we spend a little effort on this.
I know we're deep in the clock. The Builda stuff I know is like, there's been some interest there. Can you give us just a super, like the whole no dinned privileged container requirement is pretty big in my opinion.
I think that's actually one massively nice thing, because we wouldn't require having a privileged runner. We wouldn't need to have Docker and Docker. And technically, we would possibly be able to reuse a couple of hosts for some of these stages, doing pipeline optimization because we have local cache, right? The nice thing about Builda is that you're not specifically requiring some system level service to be able to do this. You can run this in a container through user namespace remapping without an issue. I think Dimitri, you recently did something with Podman, and you know what I'm talking about, where all you had to do was flip the VFS driver and off it goes.
there are some edge cases where Builda and Podman do require additional privileges on the host. So it's not like you can get away from every ugliness of D&D. But
So
yes, it does take away a lot of it.
I counterpoint with that one. For our build process, we don't need Podman. We need Builda, and we need the ability to push. Now, whether we do that push with Builda or we do that push with Scopio, who can understand the contents from Builda, then we actually, as a part of our pipeline, don't need Podman at all, which means privileged out the window.
I think we did use actually services in some cases, not just DIND, where we need to have some container running in the background. I think I gotta go and check.
Right. I'm specifically in this particular case referring to the CNG, but I know that you've done relative work within the operator recently. Okay. The other bonus of Podman is because you don't have to understand the syntax and implications of what a line in Dockerfile means or where arg goes, which is a legitimate what happened here that people have done in the past. You basically can write all this stuff in shell. You bootstrap an image with debootstrap. You basically build your base image from scratch. And then you can then install into a shroot just as you would anywhere else. And that just this time around, that shroot is your container. and then you snapshot that layer when you're done. So you can edit these scripting behaviors, and you don't have like a run and pattern, which works but is super annoying. Or having to have scripts that's only job is download, build, install. Right? It works. And we've done that in a few of our containers, but it was mostly because it's like, this is annoying as get out to try and do inside of the Docker file. We can write a script, we can pull it in, we can run the thing, and then we can actually just copy the artifact that it generates into the final container. That's what we did for part of the UBI stuff to try and make it less of an absolute pain in the butt.
One counterpoint to that, though, is that Builda does not necessarily cache the layers in between. So when you talk about large intermediary steps, you lose that thing we talked about with caching the large intermediary builds no need to change on the intro. So you'd be forced to rebuild that each time, increasing pipeline duration and increasing artifact churn.
Okay, so I would counter argument that right now we're not using it anyways.
Well, I think that's the point of we're trying to make this better. So we're not using the best practice now, but why would we not? You see what I'm saying? I'm not, we can have this asynchronous in the issue, but I'm not sold on Builda, and I love Builda, but I'm not sold on it being the best thing for this for that reason, because we do a lot of builds every day.
I think there is a kind of like, I'm a Builda fan, so like just to put it out there, Builda and Podman, but I totally feel what Robert is saying, and my experience is we can get around this by practically doing our own caching, as in like we cache the art, like we know what we're building and the intermediate stage. So certain things we can try to cache and bring in and see maybe we can actually get away with certain things. I haven't done this with the Golang, like it's much easier with the C projects because when you have the make file and the .o files and things like that, it's way easier to reassemble things when they're halfway there. With the Golang, I'm not so sure we can do exactly that, but maybe we could. So, multiple ways of skinning that portion of it.
Right, and that's a valid point in comparison on the ecosystem things, is to some degree, you do get Docker and Docker BuildX have cache from, right? So you can say, try to build this image if I don't already have it, or take the layers from this other image that I already have and reuse them if they happen to match. We do need to do a technical evaluation on that one. One of the things that we do in the CNG now is we have effectively artifact containers, right? There's a GitLab logger container, and its only content is literally the binary for GitLab logger. You can't actually execute this container, by the way. It doesn't. We could be properly making use of artifacts or pushing it to our package registry and then reusing it from that. But right now we're not, because we only have Docker. There's a number of things that are pipeline specific related, some of them that are tooling related, some of them are ecosystem availability related, because I mean, our package repositories weren't even possibly available at the time we started this project, right? DJ and I have been doing this for years at this point. There's a lot of optimizations that we can do and we can discuss. But a lot of this right now is we need to look at what we can do to optimize right now and what we can long-term iterate towards to make better. One of those things is like, how do we actually version containers? Like long-term thinking from Balu. How do we determine what version of the thing that we should be pulling from? Right? These are not optimized. There's a lot of stuff that we need to fix up. But our first impact needs to be fix the OpEx. Fix these containers that are ridiculous.
One thing to throw out there, like in line with what you said much earlier about the ARM images, and there's a possibility, and we need to make some, or we need to come to some decision at some point in time whether we want to maintain those images as a separate one, or we want to do the multi-arc images. Because with the Docker, you can have the multi-arc images, but with Builda, I don't believe you can build them. You can
You
actually
can.
do it with a Docker. Oh, okay. I
Not only
don't
that, I can
know.
show you the demo of how to do it.
Okay, good, because I wasn't aware of that. I was aware only of Docker buildx that can do this, and you can actually, yeah, there are multiple things that we can talk about, like how we can optimize our building experience.
Right. Effectively, here's the thing that people need to know. We say multi-arch. We're not saying an image that contains x86 and ARM. They're not side by side. This is not multi-live. This is not 3264 side by side. This is, you have an image that is ARM, you have an image that is x86, and then you have one manifest that has pointers to the manifest for the other one. So a multi-arch image is, you pull GitLab Workhorse, the 14.2.1, okay? That is a manifest that then points to the Docker layers. But if it's a multi-arch, it's actually a manifest that points to the architectures that are supported that point to the actual Docker files manifests for what you're trying to ask for. So you pull it on an x86 host and you get an x86 binary by default. You pull it on an ARM64 host and you get an ARM64 by default. But you can also add the tag to the end of it to explicitly get one by name, or you can override the architecture you're trying to pull for the instance of, say, Scopio.
Yeah, that's pretty cool.
Well, I know I talked about a lot of stuff, and I wanted to cover the big items, which is really the optimization of images and the OpEx result. But I wanted to touch on, documentation is out of date and it's hard to follow because we're so convoluted right now. And I wanted to touch on some of the tooling stuff, and where some of this behavior is, right? Like when I have tooling in the points above, I'm talking about Builda versus Docker versus whatever, whether it's Canico or Bazel or whatever, right? We then have the whole, because there's no central base image, everything basically depends on Ruby, which means everything is at minimum 300 plus megabytes. Kind of a waste of space, right? But then the standardization that we have to care about is, we should try to avoid move and copy and instead rather use install. That's literally what it's made for. When you're installing final locations, use this instead. We have customers out there that would much prefer that we always use copy rather than add. And we have an open issue to try and address this one. And they're not small customers. They would really like to see it fixed. But then we also need to go through all of the images and make sure that we're actually using multi-stage. And when we're building the final runtime container, we're building the final runtime container, not everything else. If we had these clear, standardized, and work outlined to go complete that work, we'd be able to welcome more contributors quickly.
One quick
Thoughts?
point. We mentioned UBI multiple times within this call, and I have that, I don't know, worry, let's phrase it that way, that UBI dependency may actually be something that we going to be struggling with long term, especially for the end users who want to contribute, because the UBI availability and things like that. Like, do we want to standardize on UBI, or do we, like, what is our relationship with the UBI long term is probably not something for this call, but something to think about long term, because I feel that moving into the Red Hat ecosystem exclusively may be the bad thing for us long term. But for example, even the certification of our images with the Red Hat requires the UBI, so it's not like we can get away without it, period.
So that's somewhat related to another topic that we have going on in regards to community versus enterprise, and a couple of things going on there. Does the fact that we have a Debian base image and a UBI base image complicate the total work required? Yes, unquestionably. And we've actually discussed this in the past. before UBI 8 came around and the separatized EULA and repo, etc., were a thing, right? We'll have to dig that out. And as with any decision, it's worth revisiting from time to time. But we decided back then that effectively, because there are folks out there who are not familiar with going in and debugging what's going on in a Red Hat based system, or really a DNF or a Yum based Red Hat like system, as composed to, as compared to a Debian or Ubuntu image, right? They're just, the familiarity is not there. And there's a trade-off between the people that don't want to get anywhere near Red Hat as their choice, and the people that don't want to rely on a non-enterprise that is Debian, right? So we got two concerns from our customers, and we're trying to make sure that we address both in this particular case.
Maybe to just finish off real quick on the epic that you referenced, the big one. That's where we should start. That's our next action, is to get some of those issues scheduled. Is that true?
So what I would like to do is, everybody who is contributing to the project, go through, have a thought on it, as I've said to people that I do maintainer training with, little carpe noctem. Look at it. Don't like, I got to figure it out. I got to figure it out. Just look at it, have a read through, and figure out which things that you think we can manage to action on more immediately, which things will have a larger impact for the acceleration of contributors, for the understanding of people, not just within our team, but certainly within our team, right? Because trust me, I want more maintainers for that project, okay? And which things can we action on now to directly impact our OpEx, both with the operation of these containers, like final outputs, right, that I spoke about, but also how fast can we get these container pipelines to actually run, because we're doing some optimization. What can we do to improve the cycle time on these things? Like, these are the larger things that people need to think about when they're looking at being a maintainer, period. But when it comes to this, large, big one, we have a lot to do, and this is not going to be a quarter. This is going to be like a year plus worth of work. And when we bring new people on in the coming year, they're going to get daunted by everything going on. What will this do to help them get up to speed even faster? Spend a little background time on that.
Sounds good. We're past time. Should we wrap it up here?
May I add one other thing, just
Sure.
on the end here? So the one thing that we didn't really cover in all this is the tail end piece that we're missing, and that is when you do a container for the CNG, you test it by deploying all of GitLab. And at some point, what we should look at is, we know that when we're troubleshooting, does this new Gitly container work? Does this new other service container work? We look at the communication by saying, can we see it connecting on this particular port? Can we see these pipes? Having a minimal smoke test set of tests that when a container is done, it spins up the container by itself and just checks, do you do these things when you're alive, right? Basic health checking. Because that way, things that just don't come up at all because something got missed get caught in the CNG pipeline, not having to do a complete deploy into like another place. And that's something we don't have today for visibility, is to when we screw up a build and get a container wrong, we don't know until much further down the process.
We're going to have to talk to QE and QA about that one. Viable, decent question. I don't know we have any functional framework to do that, whether it's in cloud native or not.
We don't, and this is one of the things that I've been bringing up, but cloud native, because it's already, but this is part of that larger build epic, the other large epic out there about our build vision, because we don't break this down into composable pieces, and because we don't have that, we have to ship as omnibus as a fast approaching the limits of what an RPM size can be, even compressed. So, this is a long term, we need to be able to do this to speed up our testing and to have more confidence, right? Because I don't know anybody else, but I loathe the fact that I have to spend 3 to 5 hours per each individual review spinning up the entirety of GitLab just to test one little piece. Only to find out it's some little thing, I got to go fix it, do that 6 times, and then I can start my integration testing, right? So we need to eliminate all that cruft from all the projects. But I think cloud native is a good first place since we're already decomposed, right? So this is the minimum viable place to start that thought experiment.
Any other closing thoughts?
So like really quick one, and it's just more a reminder because we talked about it before. We kind of brought it up, but never, probably my fault, never went with anywhere with that, is the standardize our base tooling, especially when we talk about the UBI versus Debian and maintaining both. It would be nice to know that in both platforms, there, like, we set the expectation of certain tooling to be there no matter what that platform is, UBI or Debian. So like our minimal tool set that we expect on, within the container, and then we expand on top of that as we need to. And that would be like a very, very minimal tool set. I know that we can go below that, but for example, any of the scripting or anything that's going to happen within that is going to rely on certain things to be available, and which things are we going to be bringing in as optional would be, again, dependent on that. But it's, again, it's just a reminder. I don't think we need to discuss it right now.
Sounds like maybe the crickets have crept in. Thanks,
I think
Jason.
so too.
That's a great, very comprehensive. I see all the issues in there as well that you've linked are great too. So appreciate it. Any other closing thoughts? If not, we'll step away.
Yeah, the short answer is I don't expect to see a massive progress on this in the next quarter. We got a lot of work to do. I really just want this to be aware within the group and through this demo, the rest of the company, like, we can do a lot, but we need to do a little bit of groundwork so we can accelerate the entire path.
Agreed.
Maybe to be clear, for this, we're not looking for MRs. We're looking for asynchronous communication so that we can determine the path and then start the walking on it. Because that's the thing that's gonna, if we start just trying to do it now, and Jason pointed this out, if we start doing before we decide where we're going, we'll end up in the same place. So that's that carpet noctem he's talking about, right? So
Understood. Collaboration is key on this. All right. Thanks, everyone.
Bye.